Hello everyone here, this is Eason from Think Academy Singapore. Today we are going into geometry part and talking about dovetail models. Dovetail model is a model about area of triangles. So it connects the area of triangles to the line of segments. So the most typical dovetail model figure is like the left. Here is a triangle ABC. E is a point on BC and D is a point on AE. So then we connect BD and CD. We have two triangles, ABD and ACD. The ratio of area of ABD over ACD should equal to the line of segment BE over CE. So it can be easily proved, so I would not waste time on this video. I think you all know it. Then, this is the typical figure of the Dovetail model, but the most typical figure to use Dovetail model is like the right one. So the right one here, we have a triangle ABC, right? So we have a D on BC, E on AC, and AD and BE are connected. So there are a triangle and two intersecting segments and one intersection point O. So as long as we see this figure in the question, the first thing we should do is always connect the intersection point O to the remaining vertex C. By then, we can divide this figure into three triangles AOB, AOC, and BOC, right? So this three triangles are what we call the dovetail triangles. For the ratio of area 2 by 2 can all be calculated with the dovetail model, and then we can solve the questions. Now in NMOS, dovetail model is a popular acknowledgement point to be tested in all the ratio models. So we can see maybe in this 10 years there are more than 5 questions about it. So let's look out. The first question is the last year newest question. It comes from the 2022. It's a 4-point question. So this problem can be solved in many ways, and dovetail model is one of the methods to solve it. So we have a rectangle here. So AE, EB all equals to 5, AF and FD all equal to 3. So we want to find the area of the shaded region. It's obvious that the shaded region can be cut when we connect BD. So it is formed by BDC and BDG. Of course, BDC is half of the rectangle, which is easily calculated as half of 10 to 6, right? So, it's 30. So now we know the half, the BDC is already known. Then the question is how to find BDG. Then we move to the left top part of this rectangle. Then we see here a triangle, two intersecting line, and an intersection point G. So this is absolutely the typical figure of dovetail model, right? So what should we do? We should connect AG. So by connecting AG, we divided this figure into 1, 2, 3, 4, maybe 5 parts and 3 dovetail triangles, right? So let's try to calculate the area of the dovetail triangles. So first of all, let's see what we know. So we know that for AGB and BGD, right? So we have AGB to BGD. The ratio of the area is AF to FD, which is 1 to 1, right? And again, for AGD and BGD, yeah, AGD to BGD. Yeah, the ratio of area is 5 to 5, right? It's also 1 to 1. So put them together, we will find that AGB, BGD, and AGD all shares the same area. And then, yeah, we can find out. Now maybe we let the AEG be A here, right? Then this would be A. Then AGB is 2A. Then BGD is 2A as well. And AGD is 2A. So GFD is also an A, right? And we have seen that the triangle AED, right? The triangle AED will equal to 3 A's, and which has the area at 5 times 6 and a half is 15. Then we can get 1A equals to 5, and the area of BGD is 2A, which makes it to be 10. Then BDC is 13, BGD is a 10. So put them together, the shaded region is 10 plus 30 is 40. Right? Yeah, actually there are many ways to solve it, but yeah, as we see the typical Dovetail model here, we can use Dovetail model to solve it. Yeah, this is the simple question. If you want to make the question more difficult, yeah, here comes the 2015 questions. Yeah. It's a 5-point question. Actually, yeah, this is not a good question as it gives us extra conditions. So, yeah, it tells us the AE equals to 42 and the height is 28. So, we know that the area of ABC, right? Yeah, actually this is a B here. No, this is B here. So, ABC should equal to 42, 28, and a half. Which is, maybe we calculate it. Yeah, is a 588. Right? Okay, then we want to find the area of the shaded region with knowing that AD, BE, and CF are all trisection points. Then, yeah, why did I mention that this question is not a good question? Is that this is not necessary. For as long as we know the area of the ABC, we know the position of DEF, we can calculate it out about the area of GHI. Just use the Dovetail model. So the question may be like this. So there is a triangle. Trisection. I think it's here. Yeah. So this question can be solved. But how to solve it? Yeah, maybe I leave it as a homework. Yeah, I just mentioned this question on Friday on my class, right? Yeah. So by solving this question, we firstly need to cut the triangle into 4 parts. So in middle we have the GHI we wanted, and around it are 3 other triangles. And first, which names ACI, AGB, and CBH. Yeah, separately. And yeah, in the way we solving this problem, we can have a conclusion that these 3 triangles, ACI, BCH, and ABG, they all share the same area according to symmetry. So yeah, as this question has already given us the area in the middle is 84. So now we can just directly calculate it by using the whole area minus 84, then times 1/3. So which makes it to be 168, right? Yeah. So we can find the area of ACI and BCH and ABG, all be 168. And then we want to know the shaded region, right? Say shaded region like this. Then we connect another line here. Maybe we connect BI here, right? So we connect BI. Then ACI and BCI, yeah, absolutely they form a dovetail model, right? So ACI and BCI. The ratio of area should equal to AE to BE is 2 to 1, right? So we can find BCI here to be half of ACI, which is 84. So BCI is a 84, then BIH is a 84 as well. And for BFI here, right? BFI here, which is 2/3 of BCI, right? So, which makes to be, 56. Now then, we know BIH, we know BIF. Though, then we should know that the BHIF here will equal to 84 plus 56, which makes it to be 140. And as we all know that the shaded region has 3 quadrilateral, which shares the same area according to symmetry, which you can prove before. So the shaded region is 3 times 140 is 420. So that can solve this problem. Also, this question has another different method to solve it, but using the Dovetail model is the simplest way. The Dovetail model is very important in the ratio model, so I think you all should master this model. Oh, that's all for today. Thank you.